Good morning, grade 9. Now we are going into the second chapter. Yes, we have finished one chapter. We are going into the second chapter, a part of continuation of what we have been doing last year. Now the chapter is matter around us pure? Okay, now we are going to only see a peep into what pure substances are in this video. Okay, what are pure substances? Pure substances are substances which is made up of one kind throughout. Okay, but this is the most important part, which cannot be separated by any physical methods. What are the physical methods? Evaporation, sedimentation, filtration, distillation. They are all physical methods. Now, pure substances are substances which are made up of one kind, whatever is the state of matter is, but cannot be separated by physical means. And examples of pure substances is elements and compounds. And elements are made up of individual atoms. These are all things which is a recap of what we did last year. Compounds are one or two elements in fixed proportions. Now these are pure substances because they are made up of one type. Let's take, let's say, a copper wire. It is a pure substance because it is made up of one particular element called copper. Okay, and it does not have any other element added to it unless it is an alloy, which becomes a mixture. Okay, that's a different. We'll do it after this. So elements and compounds. Now let's say for a compound example, you can say water. You take a glass of water. Water is only made up of hydrogen and oxygen. It does not have any other substance in it. So it is a pure substance because it is made up of only hydrogen and oxygen in that particular proportion. If the proportion changes, the compound itself changes. So, and water cannot be separated as two different as in physical means. Chemical means electrolysis, yes, it's a chemical method. Physical means when you break it or when you smash it or when you evaporate it, water changes directly into steam, which is water again. So by physical means you cannot separate the hydrogen and oxygen in water. So that is pure substances. That is, this particular word is a key word here, which cannot be separated by any physical means. Very important. You can underline it in your lecture notes. Okay, now elements. We will just go through the general properties of elements. Elements can be divided into three: metals, non-metals, and metalloids. Now this is important. This is a foundation for next year's one chapter called periodic table. So please pay attention. Elements can be divided into metals, non-metals, and metalloids. Now if you look at your periodic table, which I think you did last year as a holiday homework, you will see that all the metals, this is your periodic table. Now all the metals will come onto your left side. Okay, and all your non-metals will come onto your right side. Now there is something in between. Those are metalloids. So what are metalloids? Metalloids are elements which have the few properties of metals and few properties of non-metals, and they bridge the gap between the metals and the non-metals. Now we are going to see in detail about what are these properties. What do you say? Properties. Now I want you to remember this particular set of properties as a song. Right from your KG classes, you would have heard the song Old MacDonald. No, I'm not going to sing. I know you don't want me to sing. I'm not going to sing. Now let's think of this song, Old MacDonald. I wanted to play that Old MacDonald song, but I thought for grade 9 it is going to be a little too much. You can sing it yourself. Now, M is malleable. McDonald's M is malleable. C is conductivity. D is ductility. Okay. Old MacDonald had a farm, and on that farm he had Old MacDonald is very hep fellow. So he had a lion, he had a horse, he had a monkey. Okay, now I want you to remember these properties. There are 10 of them, and I want you to remember it this way. So Old MacDonald, which is the element, should be malleable, should conduct heat and electricity, should have the property of ductility. Lustre, what is lustre? Lustre is shine, hard, and its melting and boiling point. Now the elements, if it is a metal, has one set of property. Non-metal has one set of property. Metalloid has one set of property. Now, so how do you deal this? This is how you have to remember. So malleability and ductility is sheets and wires. Conductivity is whether they are good conductors or bad conductors of heat and electricity. Lustre is shine, I told you. Hard or soft? Gabriella, sodium is soft because it is sober by nature. Yes, but sodium is a metal. There are few exceptions which you are supposed to know. So most metals are hard by nature, whereas most non-metals are soft or gaseous by nature. Melting point and boiling point, it differs between metals and non-metals. Okay, song is not over yet. The tensile strength. So he also had a turtle, he had a snake, he had a cat, and he had a dog. Old MacDonald is a little cracked. Yes. So he has turtle and lion and snake in his farm. What an exciting farm. So the tensile strength, whether they are sonorous. Sonorous is whether they make noise. When you drop a metal, it makes noise. Color. Most metals are grey or silver in color, except a very few like gold and copper, which is gold in color and copper in color. Most of the metals are grey or white in color. Density. Not going back on this, we saw this in the last thing. Density is mass by volume. So the density, metals are more denser than non-metals. Why? Because non-metals mostly are gaseous by nature and metals mostly are solids by nature. So sing this song, Old MacDonald. Malleability, conductivity, ductility. Then he had a lion, he had a horse, he had a monkey, he had a turtle, he had a snake, he had a cat, and he had a dog. So find the complete properties like that. Metalloids, as I told you, is a bridge between metals and non-metals. They are found between the metals on the right, on the left side, and the non-metals on the right side. They are semiconductors. What are semi? Semi is half. Okay, now when you put a little impurity into this metalloids, they become superconductors. Okay, so by nature they are slow learners. They always take a back seat. So you need somebody to kick them, then they become conductors. Very simple. I think most of you can relate to what I am saying. Examples are boron, silicon, and germanium. Sorry. Work for the week. Compare and contrast the metals and non-metals with at least 5 examples each. Remember, I had 10 points. All these 10 points has to be written in the tablet column. Give 5 different examples of metals and non-metals. Metalloids, I have given you the example. List out the exceptions in each case. Now, metals have a lot of exceptions. For example, sodium is a soft metal. Okay, same way, list out the exceptions in each case. All the exceptions. Till next week, stay safe. Thank you.